Okay, today's lesson is going to be over a new function called quadratic. But before we talk more about quadratics, let's go back and refresh our minds about the function we talked about the whole first semester, which was linear. Linear, we talked about the slope man, which showed us our different types of slope: positive, negative, undefined, and 0. We learned how to solve for x and for y. We learned about slope-intercept form, which is y equals mx plus b, where m is my slope and b is my y-intercept. We did domain and range and found out that the domain and range of a line is all real numbers, no matter what the line is. And so we spent a lot of time on lines, and so now we're going to finally introduce a new function called the quadratic, which is a little different, not a little, it's pretty different from the linear we talked about all first semester. So on this T-chart to my left, in class we just talked about different types, or linear versus quadratic, in regards to the function equation, right? So we had like y equals x and y equals x squared. We had 2x minus 4 equals y, or 2x squared plus x minus plus 4 equals y, and then we had like negative 1/2 x equals y, or 1/2 x squared plus 2 equals y, and so on. Excuse me. So in class, we came up with the conclusion that they're pretty similar, especially if we put similar equations side by side, like the first two. The only difference is the square. The next one has a square, right? So what makes a quadratic is that exponent 2. So we're going to talk about here our summary / conclusion about the two types of functions. So a linear makes the shape of a line, obviously. It has the word line in the name. The highest exponent that it has is a 1 that the x has, so that's important. So notice here in the first one, y equals x. We don't ever write to the power of 1 for a variable. We just know that there's a 1 there. So an example of a linear is y equals, 1.5 or 0.5x plus 2, okay? Now a quadratic makes a U shape, which is called a parabola. A parabola, okay? The largest exponent on the x is a 2. So to be quadratic, the highest exponent has to be a 2 in there. So for example, y equals x squared plus 3x minus 4. Okay? So now we're going to talk about the parent functions of the two. Remember, the parent is like the mama bear. All the other, when we add numbers for example, in linear, we had y equals mx plus b. The parent function is y equals x. When we start adding m's and b's, that's a funky looking y, sorry. We start adding numbers in for m and b, our parent function starts moving up and down and to the left and to the right and so on. So the parent is the original, the one in the middle, okay? So the parent function of a linear is at the origin, is symmetrical at the origin, has a slope of 1, 1, 1, 1, 1, 1. Okay. So then for a quadratic, we have y equals x squared is the mama bear. And just like the linear is at the origin, it's symmetrical. So if I were to fold this u in half, it's symmetrical, right? Similar to this, if I fold the line in half diagonally, they would be on top of each other. So anyways, so that's what the graphs of the parent functions of linear and quadratic look like. So next, we're going to talk about different attributes of a quadratic. So like I mentioned in the beginning, when we did linear, we talked about x-intercept, y-intercept, and slope. Well, now we're going to keep the x and y-intercept, and we're going to add different attributes that go for a quadratic function. So on the first example, my function is over here to the right, y equals x plus 2 squared minus 4. So this function made this picture, this parabola right here. And we're going to talk about the different parts of this parabola that are specific to the parabola. So the main thing is a parabola has a point called a vertex. And it's going to be the highest or the lowest point of the parabola. So if I look at the vertex and I'm looking, the rest of the points or the shape goes up, that means that the vertex is a minimum. It's the lowest point of the U. Now flipped, if it was a maximum, it'd be the highest point. There'd be no point above the vertex. Every other point would be under it. And we'll see an example of that here in a little bit. Then we have this dashed line right here. We say it's an imaginary line that cuts the parabola in half. And it's called the axis of symmetry. So if I were to fold the parabola in half across this dotted line, they would overlap each other perfectly. Okay, so axis of symmetry. And then the next ones, they're about the same, but they just have different names. So we're going to talk about these 2 points right here in blue. And what they're called are, like we know from linear, they're called x-intercepts. They are the points, the 2 points that touch the x-axis. So you guys know that. And the rest of the names are new, but you might be seeing them in other higher level math or in the STAR test, but you need to know that they mean the same thing. So another name for x-intercept would be 0, roots, or why can't I remember the last one? Oh, solutions, sorry. So all 4 of these names, or well, technically these 3 are new to you. These 3 names, if you see them, they mean the x-intercept, okay? All right, so one more example. I have this function right here, y equals negative x minus 1 squared plus 4, and this function made this picture on the graph. And we're just going to identify the things that we just talked about above. So the first thing we're going to do is find the vertex. So on this one, the vertex is the highest point. So it's going to be my maximum, not my minimum. Okay, so that's my vertex. Now, the axis of symmetry, which I forgot to mention above, cuts through the vertex. So you see how the dashed pink line is going through. It's going to touch this point. Okay, well, not really touch because it's imaginary. But anyways, so the axis of symmetry is going to cut through the vertex. So same thing here. From the vertex, I can cut my axis of symmetry. So I'm just cutting the parabola in half. Okay, so that's my axis of symmetry. And what I forgot to mention above, I'm so sorry, the axis of symmetry actually has an equation. The axis of symmetry is going to be x equals the number that it cuts through. So if you go to the x value right here, that's 1. So the axis of symmetry, the equation of the line is x equals 1. So for the one above, it cuts through -2. So the axis of symmetry for this one would be x equals -2. And it's always x equals because no matter what point I pick on this dashed line, the x is -2, right? Same thing for this one. No matter where I go up on this dashed line, the x will always be 1. So that's why it's x equals. All right, now the last part is the x-intercepts. So one name is x-intercept. Another name is 0. And another name is solutions or roots. So remember, all 4 of these mean the same points, the x-intercept. Okay, and so those are some of the attributes of a quadratic function.